Kevin Kelly, Out of Control, The New Biology of Machines, Social Systems, and the Economic World. Embark on a fascinating exploration of technology and its relationship with nature, as presented in Kevin Kelly's book, Out of Control, The New Biology of Machines, Social Systems, and the Economic World. Delve into the possibilities of merging vivid logic in machines and enhancing natural systems through technology. The summary touches on vital topics such as artificial intelligence, bioengineering, bionic vivisystems, swarm systems, and network economy. Discover the challenges humanity may face in relinquishing control over these systems and the need to adopt natural principles, like autonomy, creativity, and adaptability.
Nature and technology. In the quest for greater technological advancement, scientists and technologists are looking towards nature for inspiration. By emulating the vivid logic of the human brain, machines of the future may be able to learn and evolve like organisms do. But it's not just a one-way street. Technology can also be used to improve natural systems through bioengineering and the creation of bionic vivisystems. As the line between nature and technology blurs, new possibilities emerge for advancements in both. Relinquishing control in a nature-technology merge. In the merging of nature and technology, humans must recognize nature as the dominant partner and relinquish control to allow for the development of autonomous, creative, and adaptable machines. Natural processes are more efficient than artificial ones and must be utilized by guiding the flock as a whole, rather than controlling every individual element. This shift in mindset will allow for the development of artificial systems that follow natural principles and pave the way for advancements in the 21st century. Lessons from swarm systems. Swarm systems exhibit characteristics that humans hope to attain by merging nature and technology. These systems lack centralized command, are highly adaptable, and resilient even when individual subunits are lost. The artificial version of a bee swarm is a network of nodes that can communicate information. Growing this network only requires adding more nodes, without fundamental change. Each added node exponentially increases the number of connections along which information can travel. These lessons from swarm systems can help improve technology. A network economy. The book describes how the application of network thinking to the economy can result in a network economy where individuals handle specific stages of production instead of one single company. This process creates a unique combination of nodes that might never be used again. A network economy is more ecological because goods are only produced when demanded, and recycling is encouraged. Furthermore, consumers have more power because producers must respond to specific demands, and consumers can be part of the production network as in crowdsourced software. Network privacy. Networks offer immense benefits, but they also raise concerns, especially regarding individual privacy. Network thinking requires individuals to share a lot of information, making it essential for networks to have a foolproof privacy protection method. While selective deletion of data might seem like a solution, it is not without flaws. Encryption is a better option as it renders information into a form that only authorized people can decode. Electronic cash is an example of an advanced application of encryption. With it, merchants no longer have to see a customer's purchasing history and personal information every time they use a credit card. Authentication is needed to decipher who was the payer in a given transaction. Overall, when it comes to network privacy, the right tools are necessary to strike a balance between data sharing and individual privacy. Lessons from Aldo Leopold's Prairie ecosystem. In his attempt to create a prairie ecosystem on an old farm, ecologist Aldo Leopold discovered the complexity of natural systems. Despite introducing the right plant and animal species, the ecosystem did not develop as expected because he overlooked the crucial role of fire in regulating prairies. This serves as a lesson for the future of biotechnology. Complex machines must arise from a similarly random and emergent process. To achieve this, humanity must relinquish its desire to control and deliberately design biotechnology and let randomness play a big role in the process. Overall, Leopold's experience shows the difficulty of artificially designing ecosystems and suggests that stable systems emerge over time through an evolutionary process that has a degree of randomness and uncertainty. Artificial intelligence evolution. The complex idea that artificial intelligence can evolve from an evolutionary computer program is explored in this book. The author delves into the inspiration for such a program, the human brain. The human brain is a huge decentralized network akin to a node in an information network. The book delves into how developing an artificial version of such a network would work and how it would learn and develop much like the human brain. Once this level is attained, where artificial intelligence becomes self-sustaining and self-improving, we will be very close to artificial evolution. Sharing our universe with our creation will be the greatest unintended consequence. Insights from artificial evolution. The concept of artificial evolution has immense potential not just for creating artificial intelligence, but also for deepening our understanding of natural evolution. By manipulating parameters in a computer program, we can observe and study how natural selection works. Moreover, we can alter the conditions to create an entirely different evolutionary force. This idea is post-Darwinism. Additionally, artificial evolution can teach us about natural evolution by showing that genetic mutations occur in response to environmental signals, contrary to Darwin's theory. Furthermore, evolutionary developments converge on certain shared standards that stand the test of time, similar to how the auto industry has converged on the standard four-wheeled model. Studying such patterns in artificial evolution can enhance our knowledge of natural evolution and help us question the higher power that instigated our own evolution. Finding order in chaos. Processes that seem chaotic can have some order in the apparent chaos. However, we must understand that long-term predictions are limited and our control only extends to the immediate future. The world around us can often seem chaotic and unpredictable. The stock market is one such example, with stock prices fluctuating wildly at times. However, as we learn more about the economy, we can find that many of these movements are predictable. This positive myopia helps us make short-term predictions about chaotic processes, but in the long term, it becomes outdated. Investing based on consistent movement trends will eventually lead to losses. Similarly, we can find order in the seeming chaos of an unknotted balloon flying around a room. Learning to anticipate its movements results in better control over catching the balloon. However, we must understand that we only formulate simplified rules of what happens next, and in the long term, our predictions are limited. The same principle applies to the unpredictable development of biotechnology or swarm systems. While positive myopia can help us make short-term predictions, long-term predictions are impossible. Scientists have historically been unable to predict the future better than if they made random guesses. In conclusion, while we can find order in chaos, we must understand that our control is limited to the immediate future, and long-term predictions are impossible. Accepting this is key to making informed decisions in a world that is often unpredictable.
The book's summary highlights a new perspective on the convergence of nature and technology. It underlines the importance of learning from nature in order to create innovative machines, while simultaneously enhancing natural systems through technology. From artificial intelligence and bioengineering to swarm systems and network economy, Kevin Kelly encourages readers to embrace the need for autonomy, creativity, and adaptability in the 21st century while understanding the limits of our control. Ultimately, this summary offers crucial insights into the evolution of technology, social systems, and the economic world in accordance with natural principles.